Hello everyone, welcome back to Exclusive Tutorial, and in today's video we are going to be talking about engineering mechanics, which is usually called the ME 211, specifically for 200 level students in the University of Benin. Now we are having a viral problem on the board. The problem says a school is subjected to two forces, F1 and F2, this F1, this F2, and we are asked to determine the magnitude and direction of the resultant force. Now to get the magnitude and the direction of the resultant force, we can solve it in two ways. First, we are going to be making use of the parallelogram law, and could also solve it by resolving both to either the x and the y components, and then mix up Pythagoras theorem to finish up what we have. Okay, now I'll be calling this method one. First of all, what is parallelogram law of vectors saying? Saying if two vectors are acting as angles to each other, then those two vectors can be represented by the adjacent side of a parallelogram. Okay, and then the magnitude is given as a single line drawn from the intersection of these two vectors always. Now I'm going to be drawing a parallelogram on this side of the board. Let's say we are having a vector F2 on this point, which is 150 newtons, okay, and then we're having a vector F1. We're having a vector F1 which has a magnitude of 100 newtons. Now, how do we get the angle between these two vectors? First of all, we're having a perpendicular point. We could either call this the x, or this the x, or this the y, or this one the y. Either one you want to get the same thing. Okay. So assuming here to be x and this point to be y. So I'll call here x and I'll call here y. Then we're having f1 and then we're having f2. Now the angle here is 15 degrees. The angle here is 10 degrees. Since these two components are perpendicular, it means the total angle, the net angle between these two components is 90 degrees. So to get this angle, okay, to get this angle, which I will call, let's say, Q, angle Q, it means when I sum these three angles, I'm going to get 90 degrees. So 10 plus 15 plus Q is equal to 90 degrees. That will give us Q as 90 minus 25, which is 65 degrees. So the angle between these two vectors is 65 degrees. Next thing we're going to do, we're going to complete the parallelogram. So I'm going to be having something like this. Okay, we know for a parallelogram, opposite angles are always equal. So if we're having 65 degrees here will be 65 degrees as well. Now, if we want to get the angle here, which is also same as the angle here, it is very easy. We apply geometry. Sum of the angles here has to be what now? 360 degrees. Of course, we're having a quadrilateral. We're having one side here and other two sides here. Now, to get the total angle, we simply multiply each of this angle by 2, or we are taking the sum of these angles, okay? And next, we subtract from 360 degrees to get each of these, then dividing by 2. So we're going to get 360 degrees minus 2 times 65 degrees divided by 2, which will give us each of these angles. And then we're going to obtain 360 degrees minus 2 times 65. Okay, I'm going to just punch everything on the calculator to get a straight answer instead of solving everything together. So what we have on the board is 360 degrees minus 2 times 65 divided by 2. Okay, that will give us 115 degrees. 115 degrees. Automatically, the angle here is 115 degrees. Now, the next thing we want to do is get the resultant vector. Now, the resultant vector must always be drawn, or it can be seen as a line that is drawn from the intersection of these 2 points. Okay, the resultant vector R is seen as a line drawn from the intersection of these 2 points. Now, take note that this resultant line is not a perpendicular bisector. That is, it is not dividing these two angles or these two forces into two equal parts. It's not splitting the angle into two equal parts. So we can't say that the angle in each place is 65/2. Okay, we don't solve this like that. Now we are having the resultant vector here. Next, what we're going to do is apply the cosine rule. Now, the cosine rule is saying that the resultant squared is equal to the square of each vector, that is 100 squared, plus the other vector squared minus 2 times each vector 100 times 150, okay, multiplied with the cosine of the angle that is facing the vector. So we are going to have cosine 115 degrees, okay, and then resultant vector squared is equal to, I'm going to still operate this on my calculator and see what we are going to get. So that is 100 squared plus 150 squared minus 2 times 100 times 150 times cosine of 115. Okay, so r squared gives us 45178.56 to do decimal place approximately. Now I'm taking the square root of both sides. R becomes the square root of this. So I'm going to take the square root of the answer, and that will give us 212.55 newtons, okay, approximately to 2 decimal places. So here we have the resultant force between two vectors. Now, what if we are asked to find the direction? In this case, I'm going to find the direction with respect to the force F1. You could also find it with respect to the force F2, okay? If the angle between the resultant vector and F1 is theta, we would apply sine. So we're going to be having a diagram like this. Here we have R, and then we have force F1, and over here we have force F2. We already know this angle is 115 degrees, and we need this angle theta. We don't actually need this because this is one we're looking for. Okay, now applying sine rule, we know that the resultant vector divided by sine of the angle opposite it, 115 degrees, equals, we could use force F1 if we are using this angle, but since we are getting this angle theta, we are going to use force F2. So that is F2 divided by sine of the angle theta. Now we know that the resultant force is 212.55, so I have 212.55 divided by sine 115 degrees equals F2. And F2 has a value of 150 newtons divided by sine of theta. To get sine of theta, we're going to apply some mathematical operations to what we have on the board. So that is 212.55 divided by sine 115. Okay, and that is 150 divided by the answer, and then we'll take sine inverse of the answer. That will give us an angle theta of 39.76 degrees to 2 decimal places. Okay, now what if we are asked to find the angle that the resultant vector makes with the force F2? This is the angle it makes with force F1. Okay, it makes these degrees with respect to force F1. And what if we want to get the angle with force F2? It's very easy. Since the total angle between F1 and F2 is 65 degrees, to get the angle, I'm going to call that by, it is simply 65 degrees minus 39.76 degrees. Okay, so I'm also going to do that on my calculator. That is 65 minus 39.76. That will give us the angle to be 25.24 degrees with force F2. Okay, now these are the answers to the problem. We've gotten the resultant, and then we have the direction. Okay, still on this same problem. So I would like you to do it to watch this video. If you have problems with this, you can go over it again and then drop comments in the comment sections as usual. In our future videos, we'll be talking about some more complex examples. We'll also be talking about 3D vectors. So do it to like, follow, subscribe, and also share the videos to your friends. See you in the next video. Thank you.